Factors and products for modeling with algebra tiles. Now let's try to tie this back, the strategy kind of back to when you were maybe in grade 5, maybe grade 4. Let's see how easily we can multiply 12 times 13. I mean, what I can do is I can just easily say 144 plus 12 is going to be 156. I can very easily do that because it's just one more group of 12 from 13. But what happens if we break it up a little bit? Very easily I can multiply by 10. So I'm going to say 10 plus 2 on the top to represent my 12. And I'm going to say 10 plus 13 on the bottom to represent 10 plus 3 to represent 13 on the bottom. I'm going to create kind of a chart thing here where I put a line where I see my addition signs. So I can very easily say, okay, 10 times 10 is going to be 100. 10 times 2 is going to be 20. 10 times 3 is going to be 30. And 3 times 2 is going to be 6. If I add all these things up, 100 plus 20 plus 30 plus 6, I get the same thing. I get 156. It's a pretty neat visual way of multiplying. Well, I mean, when we have factors, we're just multiplying. We can just multiply factors by each other. So one way to think about factoring is in this same way, breaking it up. So how can we use this model to identify binomial factors of a trinomial? You will need a set of algebra tiles. So I'm going to just suggest that you go to the website. It's a polypad, polypad.com. So all you would need to do is you would go polypad and look for algebra tiles. You can very easily cut up your own algebra tiles, but I actually really like this this app, and I'll show you why. So use one x squared tile, number of x tiles, and 1 tiles. So arrange the tiles to form a rectangle. If you cannot make a rectangle, use additional x and 1s as necessary. For each rectangle, sketch the tiles and write the multiplication sentence it represents. When I say multiplication sentence, I just mean the algebraic equivalent to what about 12 times 13? Okay, and I'll help you. I'll help you with that. I'll help you formulate that. Choose a different number of x tiles and 1 tiles and repeat until you have 4 different multiplication sentences. So you're going to use polypad to kind of sketch it out, or polypad to kind of design it. Then you're going to sketch it in your notes. The next step you're going to do is you're going to choose 2 or more x squared tiles and a number of x tiles and 1 tiles. Okay, you're going to do the exact same thing, but instead of just having one x squared tile, you're going to have a number of 1 and x tiles. And here's what I mean by that. So you're going to create something that looks like this. Okay, so I'm going to take 1. I'm going to use the vertical ones to go on this side. Oh. And I'm going to go to the horizontal ones to go on this side. And now I'm just going to use a whole bunch of these little ones to fill in this gap. And you'll find that you're going to see we are absolutely going to make a nice little rectangle. And what we're going to say is the factors on top are going to be x x plus 3. And on this one, we're going to call this factor x plus 2. Because my x times x creates x squared. My x times 1 becomes x. My x times 1 becomes x. My x times 1 becomes x. And then the same way this way, my x times 1 becomes x. My x times 1 becomes x. And I have 1 times 1 is 1. 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 Okay, so you're going to make something that looks like this. Remember the horizontal x's go on the vertical side, and then the horizontal x's go on the horizontal bottom. And then when we're looking for more than one, what we'll do is we'll put in another x. Okay, and say I put these 3 back. This is what we're talking about when we're looking for having more than one x squared. Okay, so I would just move this over here and create another one like this. There we go. So I would say that one of the factors is going to be 2x plus 3, and then the other factor is going to be x plus 2. So that's all we're getting you to do. And then in the next homeworky bit, because I'm going to get you to work on page 158, questions 1 and 2, it says, which of the following trinomials can be represented by a rectangle? So I'm just going to show you how I would do this first one, okay? And just, there are going to be different variables, different letters for the variables. So, you know, just don't worry about looking for algebra tile that represents y, because we'll just say, oh, that's just x squared. Okay, so we have y squared plus 4y plus 3. So how are we? I'm just going to move this. I have 1x squared, and then I have 4 x's. So I'm going to do my x's like this. 4 x's. But then how many ones do I need to make that into a rectangle? I need to have 4. But when I look back on my notes here, or look back on the homeworky bit, I can only have 3. So what I'm going to do is I can only have 3 of these. What happens if I move one like this, take away this one, and then put this one here? Haha, there we go. I have 1x squared. I have 1, 2, 3, 4 x's. And I have 1, 2, 3 ones. So I have been able to make a rectangle out of this one, out of A. So what you're going to do after you finish this this exercise, okay, making 4 different sentences, or 4 different scenarios for each one, either using 1 x squared tile or 2 x squared tiles. Once you finish that and share it with friends, you're going to work on question 1 and 2 from page 158 to see if you can actually create trinomials. And if I can just go one step further with this, I'm going to say that y squared plus 4y plus 3 is going to be x plus 3 times x. Oh, plus 1. okay? So I'm one step further, the two factors that multiply out to create x plus 4, y squared plus 4y plus 3 is going to be x, sorry, I'm in x mode, y plus 3 and y plus 1. There's nothing that you need to memorize from this. It's just kind of an exploration because we are going to be able to go directly from these trinomials to this factored form. It's going to take a lot of practice, but this is kind of the first step in getting there.